Hello everyone, welcome to Chapter 9, Section 8. In Chapter 9, we're learning about quadratic functions and quadratic equations. In the penultimate section of this chapter, that means second to last, we're going to be talking about a method called completing the square. In the previous section, we used square roots to solve quadratic equations. Excuse me. And so if we had like x to the second power equals 49, we take the square root, and the square root of 49 would be positive 7 and negative 7. So that's all stuff that we learned in section 9.7. Completing the square allows us to use square roots that may not necessarily be obvious. I need to include something which allows me to make a perfect square trinomial. I'll show you what that means. And then we can take the square root. Now, this is one of the cool things, and I wish I could post the video, or I can obviously post the link to the video, but I wish I could just show one small part of the video. There's an interesting video out there on YouTube about Euclid's elements, and in it, the narrator, I suppose, that was the word I was looking for, kind of describes how our Al-Khwarizmi, if I'm saying that correctly, the gentleman who created, or I wouldn't say create, but wrote the first algebra book, used Euclid's elements to solve quadratic equations, which means he was using geometry. The video does a much better job explaining it than I'm doing right now. And the idea was this, okay? So we had this equation, just for example. So we had like x squared plus 6x subtract, let's say 16, and that's going to equal 0. Now, what you're going to notice with this equation, and I could try to factor it, okay, I know that's another skill, but what you're going to notice with this equation is that I have this x. So I can't just like move everything to one side and take the square root to get the square root of x squared to get that. I have to do something here. And of course, you know, I picked one that's relatively easy, which means that it probably could be factored. But this is what Al-Khwarizmi did. So we added 16 to both sides, and you end up with this: x squared plus 6x equals 16. And then he went into geometry. I'll move this up a little bit so you can see it. Then he went into geometry. He said, all right, what if I have a square? And if I say the distance from here to here, I don't know, I'm going to call that x. And then each of these is going to be 1. So altogether, this is 3. All right? And then we did the same thing going this way. So this is going to be x, and this is going to be 3. So if I look at these rectangles, this rectangle, which is a square, is going to be x to the second power. It's x times x. Each of these, I'll just put dots in them because I didn't give myself enough room to write. Each of those are going to add up to the 6x. Now, this part right here is the missing part. And I'm going to cover it for just a second. If this whole thing equaled 16, well, if I complete the square here, that means I'm going to end up adding these 9 squares that I just drew in there. But I have to do that to both sides, plus 9. So then what Al-Khwarizmi was able to figure out was that by adding 9, I have completely drawn a square here. And that's called completing the square. That's where it comes from. So if I add something to both sides, I'm going to end up getting a perfect square trinomial. A perfect square trinomial means, the one that I have here is 9, and of course 16 plus 9 is going to be 25. A perfect square trinomial comes from a binomial that's being multiplied by itself. So it makes a binomial times a binomial. And you can think about this as factoring. What two numbers multiply to give 9 that add to give 6? That's 3 and 3. I get the same thing twice. And then, of course, I'm getting a little bit ahead of myself, but I would take the square root of both sides, and then I would continue to solve. That's what I'm going to be doing. So what we did, we had 1, 2, 3, 4, 5, 6. The rectangles actually represented 6x. That's that 6x. 3 of them here and 3 of them here. So what really happened was I took the 6x and I split it into half. I put half of them here, half of them here. And then I figured out what goes in this missing space that's going to complete that square. So the method that you're learning, and we'll talk about the solving equations, we'll get to that in the next videos. In this video, all we're going to do is we're going to find what number do I need to add that's going to complete the square. So I look at it this way. I'm going to have x to the second power plus something times x. I take that b, we call it ax squared plus bx plus c. I take that b and I first divide it by 2 and then I square it. That's all I do. So I did 6 divided by 2 is 3 and 3 squared equals 9. That's what I added. So let's look at a couple of examples from here, and this is pretty straightforward. And all we're doing, we're just going to put a number in the blank there. Okay, they use like a gray rectangle. Don't panic about that. So what is going to go here that's going to make a perfect square trinomial? I take my 10 and I divide it by 2. That's 5. You can think of it as 5. And after I divide, I'm going to square it. That's going to give me 5 times 5 is 25. So I get 25. And this will be the next important part. I'm going to have to factor this. What two numbers multiply to give 25 but add to give 10? Well, it's easy because I already know 10 divided by 2 is 5. So this is going to be x plus 5 times x plus 5, which is x plus 5 squared. All right, let's look at this one. And of course, if I'm going too fast, just pause it, rewind it if you need to. I'm going to take this 12 and I'm going to do the same thing. 12 divided by 2. I already know that that's 6. 6 to the second power, 6 times 6 equals, I'll use an arrow, 36. So I'm going to add 36 here, which is going to give me a perfect square trinomial. And what is the factored form of it? X plus 6 times 6 is 36, and 6 plus 6 is 12. And of course, 12 divided by 2 is 6. So it's going to be x plus 6 to the second power. Now, here's one of the problems that comes up though. You're always going to start by dividing by 2, and then you're going to square it. That's nice if the number is even. Even numbers are multiples of 2, so you're going to get something nice. 10 divided by 2 is 5, 12 divided by 2 is 6. But what happens if you start off with an odd number? Well, you're going to end up with a fraction, but that's okay. This is going to be negative 9 divided by 2. Now, you do not have to change that to negative 4.5. I want to really start to walk away from, as soon as you see a fraction, you got to change it to a decimal. You do not. You do not have to change it to a decimal. After I divide by 2, I'm going to square it. What does that mean? That means I'm going to take negative times negative, which is going to give me a positive. 9 times 9 is 81, and 2 times 2 is 4. You can just leave it like that, 81 over 4. And that 81 over 4 is going to go there. When I factor it, I take this negative 9 over 2, and I write subtract 9 over 2. Square it. Now this last one, I threw this in there because we don't want you to be fooled by anything. Notice that it was x squared plus bx, x squared plus bx, x squared plus bx, even though it's a subtraction. This one's just turned around. So I just have to turn these around and put them in the right order. Put it in what we call standard form. So I get x squared plus 8x plus something. 8 divided by 2, I think I might have to get a new marker, is 4. 8 divided by 2 equals 4. and 4 squared equals 16. So this is going to be plus 16, and it would have been the same up here too. And this 8 divided by 2, which equals 4, that's going to give me x plus 4 squared. So this polynomial factored is x plus 4 squared. Okay, now we're going to be seeing that in the next videos where we're going to be using it to solve equations.